All right, so in the next one, we're looking at something called the hydraulic principle. And with the hydraulic principle, if you have pressure in one part of a system, so say from a piston pushing on a fluid, then that's going to put pressure through the system, and it'll be the same on the other end. So in pressure one and pressure two, you could even think, I guess, piston one, piston two, but they're going to feel the same amount of pressure. And where that's handy is we can, piston's a solid object. We can think back to our earlier formula where we had force divided by area. Well, tubes and hoses and pipes and pistons are usually round, so that area we can think of as pi r squared. Then to differentiate between the different ends of the system, we put, ones and eventually twos on it. And so we can have this as a working formula. Now the nice thing about it is both of these have pi, so we can actually cancel those out. Kind of eyeballing the question, we've got radius compared to radius, so they match each other, and that matches what the formula wants. We've got newtons of force, and we're looking for newtons of force, so that's good. Centimeters and centimeters a lot of times would be an issue, but even if we were to convert this, that conversion would actually cancel itself out and give back to the same answer. So we can actually just jump straight in from here. Find what corresponds. We have a 23.24 Newton force that goes along with a 2.66 centimeter radius. The part you have to be careful not to forget, though, is that gets squared as a leftover part of the area formula. Then I don't know the force at the other end of the system, so let's call that F2 for now. But I do know the radius that corresponds to it, 7.51 centimeters. Again, squared because of our formula. So we can see corresponding units, centimeters and centimeters, would get squared and then cancel each other eventually. And then newtons are left over, so that means we're getting what we want there. And we need to work this down. So we want to cross multiply, but don't forget these exponents. So like force times 2.66 times 2.66 will give us 7.0756 times that force that we still don't know. Then in the other direction, 23.24 times 7.51 times 7.51 again is 1310.738, and so on, so on. Presumably that number's on your calculator screen, so you shouldn't be typing that back in again. We'll just finish up with the last bit of work then. We're looking for F, so if we divide by the 7.07 number that's in front of it, and then do the same thing to balance the other side, we will find that the second force is 185.25 newtons. So notice that it's 8 or 9 times bigger than what we had before.